Let me explain program using 8051 microcontroller. We are going to use assembly level programming to work upon microcontroller. What is assembly level programming? Assembly level programming will consist of instructions. The instructions are short form of English, which are called as mnemonics. So the assembly language is nothing but symbolic language. We have to assemble the program in assembly level language onto my machine language or binary language, for which we need a tool. So that tool is, as you can see here, as an example, Keel Mu Vision is one of the software tool, application software, which is IDE, that is Integrated Development Environment, where it allows assembly level program to be entered, edited, and converted into hex code or machine code. Let me click it open. So if there is a program already on the screen, let me erase it. Let me close that project and let me start my own project. A project is nothing but a group of files. Files could be your programs, individual programs. So I go for new Vision project. So a project will be started off with a target device. That means the device over which you are going to do the programming. So let me give some name to it. Say ESC 222 will be the name of the project. When I try to save it, it will ask for the device that you are going to use as the target device over which you are going to carry out the project files. So I'll open Atmel. Though you are aiming for 8051 Intel made, compatible from Atmel can be selected. So let us find out the device which is compatible with 8051. So 89S52 or 89S51 is compatible. I'll just select it and add it to the project. So do you want startup code? I'm only using part A, that is I'm not downloading it. So startup code is not required if I'm not downloading. So I would just say no, I don't need startup code. That is supporting software, I don't need. So target device has come, that is one which is compatible to 8051 from Atmel. Now in order to enter the program, I go to file. I would opt new so that the editor screen opens up. Now I have already copied a program into the buffer which I am going to paste it here. So this is the text of a program. This becomes a program only when I save this program with an extension of the program concerning program extension. So I am going to save it as say address, because I'm going to use addressing methods, addressing modes. So ADDR yes would be the name I'm going to give. When I save it, now this becomes a program. It was just a text, now it has become a program when I try to save the file with a yes extension or ASM extension. So any file becomes a program when I add the extension to it. So I can see the first instruction. The first instruction here is I am putting R5 with 55H. That means I am using immediate addressing mode here. Whenever hash comes, it is immediate addressing mode. So there are various addressing modes. So here in this example, I am demonstrating immediate addressing mode with an hash. So this is the data 55. H is the type of number system, that is hexadecimal. So 55 data is transferred to a register, namely R5. So this is immediate addressing. So immediate addressing is a method where the data is mentioned in the instruction itself. I have got a register starting from R0 to R7 in each register bank. So I am using R5. What is a register? Register is a memory storage available inside the chip or inside the system of a microcontroller. So R5 is put with 55. So that is the first instruction. Next instruction you can find move R4 comma 60H. That means 60 is the internal RAM from where whatever the data stored within 60 will be transferred to R4. So this is direct addressing. Direct addressing is the one where address of the memory location is mentioned. So it is internal RAM. Internal RAM will extend from 00 to 7F addresses. So 60 is the address of the internal RAM from where the data is transferred to R4. Now next, in the third instruction, I am again using move instruction immediate addressing to transfer 61 to R0. So this is an immediate addressing where 61 hexadecimal number is transferred to R0. Why am I doing that is R0 is now going to be used as a pointer to the internal RAM location 61. That is what I understand when I go to the next instruction. In this instruction, I understand only that R1 hexadecimal number with immediate addressing with hash is transferred to R0. That's what I understand. But in the next instruction, I realize this is indirect method of transferring from the location internal RAM of 61 to the A. Or at R0 indicates internal indirect addressing to the internal RAM. R0 points to 61. From 61, whatever the data that is saved in 61 is transferred to register A. This is indirect addressing method of data transfer. Now, whatever the data that has come in register A is transferred to R3. So here from the internal RAM, indirectly data transferred to register A. So there are register A and register B also. Register A is the special function register. There are 21 special function registers in 8051. Register A is one among them. So from internal RAM addressed by R0, pointed by R0, the data from 61 is transferred to register A. From register A, we are transferring it to R3. So this instruction demonstrates register to register data transfer. Now, I am going to use next instruction with DPTR. DPTR is data pointer. It is going to have 16-digit value in this instruction, which is immediate addressing. Wherever hash comes, it is immediate addressing. DPTR is not single register. It is the combination of DPL and DPH. That is because 8051 is an 8-bit microcontroller. That means the internal data RAM and the registers, arithmetical and logic unit are all 8-bit. So, but you have got to hold 16-bit or 4-digit address for external memory. Internal memory is addressed by 2-digit. External memory is addressed by 4-digit. Now I am handling external memory to be pointed by DPTR. So DPL and DPH coming together as DPTR to hold 0010 as the immediate value transferred to DPTR. Now in the next instruction I understand DPTR is working like a pointer to the external memory 0010. Now you can find X here. X indicates external memory. So data from external memory pointed by DPTR is transferred to register A. From register A, I am transferring to R6 in this instruction. To terminate the program, I am using this particular instruction which says short jump to the same place. That means the ending instruction suspends the execution of the program, that keeps executing the same instruction until you give the next command to the machine. End is an assembler directive. What is this assembler directive? It is the instruction given to the assembler. Assembler is nothing but the software tool which converts assembly level program into machine code. So end is the one which is called as assembler directive. So here in the first instruction I am using immediate addressing to transfer 55 to R5. In the next instruction, I am using direct addressing to transfer from internal RAM 60 to R4. In the next two instruction, I am using indirect method to transfer data from location 61 to register A. Here R0 is being made as pointer to 61. I have the option of making internal RAM to be pointed by R0 and R1 only, not any other register. So here from the location pointed by R0 is transferred to register A. Here from A to R3 I am transferring. You should also observe no instruction can involve two registers between R0 and R7. That means, for example, R4 to R3 transfer is not possible. Another Intel concept we should understand is the end one is the source, middle one is the destination. Here, move is the opcode, R3 is the destination operand, A is the source operand. So there are 2-byte instruction as you can find here. 55 is 1 byte, move R5 is another byte. So 2-byte instruction you can find there. This is 1-byte instruction, like that. This is 3-byte instruction. So opcode followed by 2 operands you are going to find in some instructions. So instruction can be categorized as 1 byte, 2 byte and 3 byte in 8051. So you have got the program now. You have to add it to the target device. So I press plus here to open up target one. Right click, add a file, this file to the group. So what name have I given to this? So let me take it to all files and I give the name ADD. So here it is. I click that and I add it to the source and close it. So I have added that program to the source. It has come here. Now I have to build this program. I go to this symbol tool to build. So it is getting converted into hex code. As you can see, there are no errors, either warning or severe. So it is true. Now I can go on for execution. How do I execute? I go for debug. So in the debug mode only I can execute. It says 2 kilobyte of program memory. That's okay for me because my program is smaller. I'll make it okay. So now it is ready for execution. Now I have to prepare the source. What are the source? Internal RAM 60 and 61 are involved. I have to put values so that I can find it to be transferred to R4 as well as to R3. How do I put a source data into the memory? I go to view, memory window, I take memory 1. If it doesn't open, again view, I go to memory 1. Once again it opens now. Internal memory will have D colon. So D colon you have to apply for the internal memory. 0x 0x stands for hexadecimal. All numbers are employed in hexadecimal. So 60, hexadecimal 60, enter. Now it has opened up. Now I take it to the upways. I enter the input at 60 as 99. So 99 is going to be found in R4 as per this example, and into 61, next location I am entering 88. So 60 and 61 internal RAM location has got 99 and 88. They are going to be transferred to R4 and R3 as you can find in the program. So 99 in R4, 88 in R3 that you are going to find. Now 0010 is another memory, external memory involved as the source. So let me also put input data into it. Now I choose memory 2. Now X colon. For internal it is D colon. For external it is X colon. 0010 is the memory location I have chosen. I have to put 0x here also to represent this 0x0010, represent this as hexadecimal number. 0010 has opened up. Here I'll put 77. So 77 is the source data in external memory which is going to be transferred to R6. So from location 60 it is going to be transferred to R4. From 61 it is going to be transferred to R3. From 0010 77 will be transferred to R6. So let me also arrange memory 1. Memory 1 here. So memory 1, 60 has got 99, 61 has got 88, 0010 has got 77, which are going to be transferred to internal register. Now I have to execute the program so that I can find the data transfers. So I run it and stop it to verify the result. So 60 has got 99, that is transferred to R4. I have to expand this. So 6R4 has got 99 being transferred from 60. From 61, that is 88, is transferred to R3. You can find R3 being transferred with 88. From external memory, that is 77, from 0010 is transferred to R6. So 77 has been transferred to R6. In the first instruction here, R5 got 55 by immediate addressing. You can see R5 being put with 55. So this program demonstrates data transfer by different addressing mode. First one being the immediate addressing mode having hash. Second one demonstrated direct addressing data transfer from internal RAM. Then from internal RAM, data transfer by indirect method using @ symbol. Then data transfer from external memory using DPTR, and you can find X here to represent it as external memory. This is how this program works. Thank you so much.